Okay, I thought we'd do some more problems. Just I'm going to pick some random ones. These might not take too long, but just to show you little things that sometimes people get confused about. Let's look at 41. 41 says y equal cosine 3x. Okay, so if you're thinking about this whole idea of the chain rule, what we're doing is we're kind of looking at it like there are two functions here. One is the function 3x, and it got plugged into the function cosine x, okay? So what you do here is you go, okay, I can take that 3x, let me call it u, so I'm letting u equal 3x. What I'm going to do is, if you remember, when I take the derivative of this function now, cosine u. The derivative of the cosine is the negative sine of u. But now I have to take the derivative of the u with respect to x. And remember, u is 3x. Well, what is the derivative of u? If you come over here, you can do it. If u is equal to 3x, du dx, the derivative of u would be just 3. So my derivative is negative sine u times 3, or negative 3 sine u. But it's not really u, is it? Okay, so you just go back and you stick in what was u? It was 3x, and you're done. We'll look at 43 has just another little. Sometimes the things that are the simplest can look the hardest to us. I don't know if y'all feel that way, but sometimes I know with this stuff I remember feeling that way. Okay, so what you can do if you want to is say, I see that I've got the tangent of this, and that could be its own function. It could be like I had a function and I plugged it into the tangent of, u or something. So let's let u be 4x. I know I'm going to have to take the derivative of this in a minute, so I'm just going to go ahead and do it now. Du dx is 4. Now, if I want to take the derivative of g prime x, I'm taking the derivative of 3, let me rewrite this, g of x, or g of u, I guess I should say, is 3 tangent of u. Alright, so if I take the derivative of u with respect to x, because I'm using u's now instead of x's, but it would be 3 times the derivative of the tangent. I have to flip because I always forget it. It's secant squared, so it would be 3 secant squared u, but then I've got to write the derivative of u with respect to x. Okay, well, if you look at this, it would be 3 secant squared u, and then du dx is 4. So we've got 12 secant squared u, but we don't want secant squared u. We actually want to go back now and back substitute. Our function was really 4 of x, wasn't it? U was really 4 of x. There's our derivative. Going with some of these in case you get stuck on any of them, you can just scroll to the one you need. I was thinking 45 looked like it had just a little bobble with it too. 45 was y equal sine of pi times x squared, okay? So if you think about this one, what we could do, this could be, we could look at this, you could do a couple of different things, but let's do this. Let's let u be pi x. If you're kind of wondering about that squared, they wrote it in kind of a confusing way. Sometimes I wish they'd have a different way of writing this. You have to look, let's kind of look at this. What they're doing is they're saying this is the sine of pi squared x squared. If they'd wanted it to be sine squared, they could have written the 2 over here if they wanted the whole thing to be squared, but they're just squaring what's in parentheses there. It gets kind of confusing sometimes, the notation what the trig functions does. So actually, let's let u be all this stuff in parentheses, okay? So if I come over here, u is pi squared x squared. We know we're going to have to take the derivative of that. We're going to use it in a minute. I'm just going to go ahead and do it. When I write my u down, I just go ahead and take my derivative. Pi squared is just a constant. The derivative of x squared would be 2x, right? So this ends up being 2 pi squared x is the derivative, okay? So if I look at my function now, here's what I've got, sine u. And I'm taking the derivative of u with respect to x. Okay, well, the derivative of sine is cosine. And du dx is this 2 pi squared x over here. All right. Now, I don't really want cosine u. What was the u really? Well, it was pi squared x squared. I'm going to write it the way they did starting out just because, just to be consistent with their notation. I could have put pi squared x squared, but I'm going to write it because, again, look up here. That's how they wrote it. That's a little confusing to me. Times 2 pi squared x. Okay, so maybe what we do is we come out front. We put 2 pi squared x cosine pi x squared, and that would be our answer. That's very weird looking, isn't it? But anyway, that's how you do that one.